Good evening friends. Last class we studied what is chemical reaction and how can we recognize a chemical reaction. Today's class we are going to study about what is chemical equation. What is a chemical reaction? When one or more substance, that is A plus B, one or more substance reacts together to form one or more new products, C plus D. That is known as chemical reaction. So when one or more substance reacts together to form one or more new substance which is entirely different from the reactants. When one kind of chemical reaction was taken place, how can we express that reaction to others? Chemical reaction can be expressed or represented with the help of a chemical equation. So we can able to express our chemical reaction to others through chemical equations. What is chemical equation? Chemical equation is the symbolic representation of a chemical reaction. One reaction was taken place, that reaction was expressed with the help of a chemical equation. What is chemical equation? The chemical equation is the symbolic representation of a chemical reaction. In this chemical equation, we use symbols or formula of the reactants or products to the viewers. Viewers means other persons. If I done one experiment, and how can I express my results to others? Through these symbols and formulas. For example, formation of water. How can water form? Hydrogen reacts with oxygen to form water. So hydrogen reacts with oxygen to form water. This is a simple example of chemical equation. So I want to express the formation of water to others through this chemical equation. Hydrogen reacts with oxygen to form water. In some cases, we doesn't know the symbols of our substance, but we know the name of the substance. How can we express? Through word equation. How can we write the formation of water? Hydrogen reacts with the oxygen to form water. Similarly, carbon burns with oxygen to form carbon dioxide. These are some of the examples of word equation. If we doesn't know the symbol of the reactant and product, we should express our chemical reaction through word equation. And this word equation, the reactants are changed to products placed in between the reactants and product one arrow. So in word equation, we write the reactants on the left hand side and products on the right hand side. In between the reactant and products, one arrow is placed between them. Writing a word equation, we use our familiar example, burning of magnesium ribbon. We doesn't know the symbol of magnesium and oxygen, we use word equation. So magnesium burns with oxygen. What will form? A dazzling white flame with white powder. So burning of magnesium oxide is formed. Magnesium oxide is formed. So magnesium ribbon bonds with oxygen to form a dazzling white flame with white powder of magnesium oxide. Here what are the reactants? Magnesium and oxygen, and what are the products? Magnesium oxide. See how long this word equation. So we want to simplify this word equation using formulas. So what is the formula of magnesium? Mg, and oxygen O2 to form magnesium oxide MgO. This is the simplest way of writing a chemical equation. We are going to discuss how do we write a chemical equation. What are the steps involved in this chemical equation? So if we want to write a chemical equation, what is chemical equation? Chemical equation is a symbolic representation of a chemical reaction. First we take one simple chemical reaction, burning of magnesium ribbon. What are the reactants here? Magnesium and oxygen are the reactants, and magnesium oxide is the product. We are writing a chemical equation. Always the reactants are written on the left hand side with plus sign between them if one or more reactants are present. So what is our reaction? Burning of magnesium ribbon. Here what are the reactants? Magnesium and oxygen. So these are reactants. These reactants are always written on the left hand side. A plus sign is in between them. So oxygen. These two are reactants. So reactants are always written on the left hand side. LHS means left hand side of our board. Next. What is our product? Magnesium oxide, that is MgO. The products are always written on the right hand side with the plus sign between them if more than one products are formed. Here only one product is formed, so we are writing MgO. Throw an arrow placed between them. Throw an arrow placed between them. This magnesium oxide is a products. Products are always written on the right hand side or RHS. So first step is reactants are always written on the left hand side and the products are always written on the right hand side. Throw in between an arrow is placed between. Arrowhead is always faced towards the product. This arrowhead indicates the direction of our reaction. That means our reaction is forward reaction. So our arrow is always pointed towards the products only. Write reactants and products. Throw an arrow placed between them. It shows the direction of our reaction. Then we should mention the physical states of our reactants and products. Whether our reactant is in solid state or liquid state or gaseous state. Here magnesium ribbon is in solid state. So S for solid and L for liquids and G for gaseous, A for aqueous solution. And oxygen is a gas and magnesium oxide is a white powder. So it is also in solid form. So yes. Example, potassium bromide reacts with barium iodide to form barium bromide and potassium iodide. Here what are the reactants? potassium bromide. Potassium bromide formula KBr. It reacts with the barium iodide BaI2. These two are reactants. Reactants are always written on the left hand side. In between an arrow is placed. Then what are the products? Potassium iodide and barium bromide. These two are products. Here two products are formed. So products are always written on the right hand side with plus sign between them if case of more than one product is formed. Here two products are formed. So we put a plus sign in between the two products. What is the next step? We should mention the physical state of our reactants and products. Here, all the reactants and products are in aqueous state, AQ. So, we are putting AQ. What is meant by this aqueous state? Aqueous state means our reactant is dissolved with the water. So it is a form of solution. Means potassium bromide is dissolved with the distilled water. So it is in the state of aqueous solution condition. And barium iodide is also dissolved with the distilled water. So it is also in the condition of aqueous solution. And the formed product is also aqueous solution case. In some reaction cases, precipitation is formed. This precipitate can be expressed by putting a downward arrow. This downward arrow indicates the formation of a precipitate. We study this through one example. Lead nitrate. Lead nitrate reacts with the potassium iodide to form lead iodide and potassium nitrate. Here what are the reactants? Nitrate and potassium iodide are reactants and lead iodide and potassium nitrate is products. In between an arrow is placed. The arrowhead is always point towards the products. This arrowhead indicates the direction of our reaction. Next what's the? We should mention the physical state of our reactants and the products. Lead nitrate is in which condition? Aqueous condition. And potassium iodide is also an aqueous solution. And lead iodide is an yellow precipitate. So this lead iodide is a yellow precipitate and potassium nitrate is in aqueous solution condition. So this precipitate can be expressed by an downward arrow. So in the case of a precipitate is formed in our products, we should put a downward arrow. It will indicate the presence of one precipitate. The product or the compound is in precipitate condition. In some reaction cases, reactants react together to form products. While forming the products, one of the product a gas is evolved. Say one example, zinc granules reacts with the hydrochloric acid to form zinc chloride and hydrogen gas is evolved. So zinc granules. So zinc is in solid state. It reacts with the hydrochloric acid, that is in aqueous condition, to form zinc chloride and a hydrogen gas is evolved. When a gaseous reactions, a gas is evolved, it can be represented by putting an arrow upward. While our product is in the precipitation condition, we are putting a downward arrow. If a gas is evolved, we should indicate the evolution of gases through this upward arrow. Fluoride is in aqueous condition. Hydrogen gas is evolved, so we are putting an upward arrow. Then while we are writing a chemical equation, we should mention some special conditions of the temperature, pressure, catalyst. All are written on above or below this arrow. When carbon monoxide gas reacts with hydrogen gas at 340 atmospheric pressure to form methanol. Methanol is in liquid condition because it is a pure methanol. Still it does not dissolve with water. It does not react with any water condition. So this is a pure ethanol. So while we are writing a chemical equation, some conditions of temperature, pressure or catalyst are involved. We should mention the temperature, pressure or catalyst above or below the arrow of our chemical equation. When we conduct some experiment, reactant reacts together to form products. While the formation of the product along with some kind of heat is evolved. For example, burning of charcoal. That means burning of coal. It is carbon burns with oxygen to form carbon dioxide with more amount of heat is evolved. This heat can be expressed by triangle or plus heat. We rate heat. So carbon reacts or bonds with oxygen to form carbon dioxide with the evolution of more amount of heat. While we are cooking food through wood, our wood burns, formation of large amount of heat is evolved and carbon dioxide gas will be in the form of fume state, smoke. What are the steps involved to write a chemical equation? Reactants are always written on the left hand side and products are always written on the right hand side. Through an arrow is placed between them and the arrowhead is always point towards the products. This arrow indicates the direction of our reaction. Then we should mention the physical states of our reactants and products, and in some cases some special conditions are involved as temperature, pressure and catalyst. Then one of the important thing is we should know whether our equation is balanced equation or unbalanced equation. See, this magnesium reacts with oxygen or magnesium burns with oxygen to form magnesium oxide. This reaction is balanced equation or unbalanced equation. This is an unbalanced equation. How can we say? Here 1 mole of magnesium is present. That is 1 magnesium. 1 magnesium is present. In the product case also 1 magnesium is present. But in oxygen, 2 oxygen is present. 2 oxygen is present. It is O plus O. 2 oxygen atom is present. O2. Here 1 oxygen is present. So it is an unbalanced equation. This unbalanced equation is otherwise known as skeletal of chemical equation. This unbalanced equation is otherwise known as skeletal chemical equation. Skeletal chemical equation. What is skeletal? If our body without shows these tissues, flesh, blood, organs, we are saying skeleton of our body. Like that, without balancing our chemical equation is known as skeletal chemical equation or unbalanced chemical equation. So we should balance our chemical equation. This balancing of chemical equation is based on law of conservation of mass. What is law of conservation of mass? Mass can be neither created nor be destroyed, but the total mass of the reactant can be equal to the total mass of the product. That is, the number of reactants and products before and after the reaction is equal. So here one magnesium atom reacts to form one magnesium in the product also, but if two oxygen atom reacts to form one oxygen atom, so we should give 2 here. Now oxygen is balanced but magnesium is not balancing, so we are putting 2 here also. Now see this equation, all the reactants and products are equal in mass. So balancing of chemical equation is based on law of conservation of mass. What is law of conservation of mass? Mass can neither be created nor be destroyed, but the total mass of the reactant can be equal to the total mass of the products. Here 2 magnesium atom reacts with the oxygen molecule to form 2 magnesium oxide. 2 and 1 r means mass of our reactants and products. It is represented in moles. So 2 moles of magnesium reacts with 1 mole of oxygen molecule to form 2 moles of magnesium. Form 2 moles of magnesium oxide. So while we are writing a chemical equation, we should write reactants on the left hand side, products on the right hand side. In between the reactants and products, an arrow is placed. Then we should mention the physical states of our reactants and products, whether our reactant is in solid state, liquid state or gaseous state or in aqueous solution state. Then we should mention the special condition states like temperature, pressure, catalyst, etc. Well, when a gas is evolved one of us our product, we should represent it by upward arrow, and a precipitate is formed as one of our product, we should represent it by putting downward arrow, and the evolution of heat is expressed by putting a triangle or heat. We are writing heat. Then we should balance our chemical equation. Then we should check whether our chemical equation is balanced or unbalanced equation. If our chemical equation is unbalanced equation, we should balance our chemical equation. These are the steps involved while we are writing a chemical equation. Next we see some questions based on today's video session. What is the name given for the substance that reacts and forms in a chemical reaction? The substance which reacts in a chemical reaction is known as reactants. It is the name of the substance which formed, newly formed substance is products. So reactants and products are the answer of this question. Next question is, write the skeletal equation and balanced equation for the following reaction. What is the reaction? Potassium bromide reacts with the barium iodide to form potassium iodide and barium bromide. First we write the skeletal equation. What is the formula of potassium bromide? Kbr. Kbr reacts with the barium iodide. Formula BaI2. to form potassium iodide. Potassium iodide formula Ki plus barium bromide, barium Ba, bromine Br2. The skeletal equation of this reaction. Here we should write the physical states of our reactants and the products. KBr is in aqueous solution condition, barium iodide is also aqueous solution condition, potassium iodide is also aqueous solution condition, and barium bromide is aqueous solution condition. Next we write balanced equation of this reaction. See here 1 mole of KBr means 1 potassium, product also 1 potassium. Bromine here 1, but here the product is Br2, 2 bromine atom is present. Then barium, 1 barium, product side also 1 barium. But iodine, 2 iodine atom is present, but in the case of this product 1 iodine is present. So we should balance. For this equation we are putting 2 here and here 2. Now we see 2 potassium atom, here 2 potassium atom. 2 bromine atom is on the reactant side, and here also 2 bromine atom. Then 1 barium atom, product also 1 barium atom, and 2 iodine atom is present on reactant, and product side is also 2 iodine atom is present. So it is a balanced equation. So we write in separately. This question, the skeletal equation is KBr plus BaI2 gives Ki plus Br2. Next we write the balanced equation. So 2 KBr in aqueous condition reacts with the barium iodide BaI2. It is also in aqueous condition to form potassium iodide. 2 moles of potassium, 2 moles of bromine. So 2 plus this also aqueous condition. Then barium bromide Br2, Br2. It is also in aqueous condition. This is a balanced equation of this reaction. Balanced equation. We see both the reactants and product side. The mass of the reactant and product is equivalent state. Next question is, complete the missing component given as X and Y in the following chemical equation. Zinc reacts with the sulfuric acid in aqueous condition state to form zinc sulfate and hydrogen. Zinc reacts with the sulfuric acid to form zinc sulfate and hydrogen gas is evolved. So Y is a gas. They are representing gas. Evolution of gas is in upward arrowed. Then X. Zinc sulfate is in aqueous solution state. So X is aqueous solution state. AQ means aqueous solution. Zinc in solid state, it reacts with aqueous condition state of, it means distilled sulfuric acid to form zinc sulfate solution, aqueous state, and hydrogen gas is evolved. This is the answer of this question. So friends, today's video session we study what is chemical equation, how can we write a chemical equation, and based on this we study some questions. I hope this video session will be helpful to you. Please like, share and subscribe my channel. Thanks for watching.